Okay, so we're looking at matrix multiplication. So say we're going to multiply one matrix with another matrix and we get an answer. So we might call it AB like that. Now what this answer matrix is called, so this one here, it's referred to as the product matrix because it was the answer to the product of two, product meaning multiply. So just so you know, the answer, the product matrix, is the answer matrix to multiplying two, yeah? Two matrices. Okay. All right. So that's what we're going to look at today. There's a couple of things that have to be present or rules that have to be applied for you to be able to multiply matrices. And so when we're looking at these, so here we've got matrix A and we're multiplying it with matrix B. And I'm just, like we called it another name, which they may do, but just so you know, I'll just call it AB, knowing that you've multiplied those two together. All right, so if we look at these two matrices that we're going to multiply together, they're going to have their own order. So say, for example, I'm going to say matrix was a 2 by 3. Okay, and then I'm going to say that matrix B was a 3 by, I'm going to say a 5. Okay, so to be able to multiply two matrices together, the columns in the first matrix, so that is this second number, represents the columns in the second matrix, has to equal the number of rows in the second matrix. So they have to be equal for it to be defined. That means we can calculate it. So if they are equal, it means you can multiply. And what happens is your product matrix here, so I'll call it the product matrix, is going to have an order of the rows of the first one and the columns of the second one. So what we're going to see there is our answer is going to be a 2 by 5 if I was looking at that example. Okay? So when they ask if they ask you to explain why these matrices can be multiplied, you must write this statement here. So you'd be writing the number of columns in the first matrix equal the rows in the second. So we might write a little example there. So I'm going to say matrix all right, matrix AB is defined because the number of columns in matrix A equals the number of rows in matrix B. Okay, so you must be writing that. So if they say explain why can it happen, you must write that statement. So this must be written. You can't do what when we do this up here, we say they're equal. We're just doing that to check before we actually do the multiplication, okay? But if they say explain why, you must have this wording, okay? And it's a good 1 mark that you will get. Okay, so we've just seen, we've got the two rules that we need. So the first one is there, written there. So for a two matrix to be multiplied together and to be defined, we need the number of columns in the first matrix to equal the number of rows in the second. So if you have a look at these example here, so if I put the orders underneath, so this one's a 2 by 3, this is a 3 by 1, and this is a 2 by 2. So if we just had a look at a couple, so if I looked at multiplying A with B, so we would see this is a 2 by 3 with a 3 by 1. Okay, it would produce the product matrix AB. So if you look, yes, we can do it because the columns in A equal the rows in B. And my answer is going to be a 2 by 1. Yeah? So that's thing. So this one we would say is defined. Okay, if we looked at, let's look at A times B. So if I did, B times A. So if I do B times A, so underneath B is a 3 by 1 and A is a 2 by 3. Okay, now because this is not equal, that one is not possible, it's not defined. So we'd say not defined. And if they said why, often the question is it possible to multiply these two matrices? So this one you would say this multiplication cannot be done. Oh my god, I can't spell. Sorry. So this multiplication cannot be done. And we're going to say because, and we're going to say the same statement, but just say no. So because the columns in B do not equal the number of rows in A. Okay, so if you have to ask why, it's just you say it's because not, but that statement still needs to be there. So here too, they also tried AC. So if we looked at A times C here, so here we get an answer AC. So A is a 2 by 3 and C is a 2 by 2. So that one is not defined. So probably shouldn't even really have that. This one not defined as well, undefined. So in a minute we can do these multiplications on our calculator, but we do need to know manually how it's done and what we're doing, and that's very important. So today we'll be doing it very slowly, working that out. But if you type these two matrices in your calculator, it will spit out undefined if it can't be done. Okay, and now obviously our second rule shows us if it is defined, it means we'll take the rows of the first one and the columns of the second one, and that'll be the order of our answer. So hopefully you noticed there that if you times matrix A, if you would have seen, if we times matrix A by B, it's not the same. It does not equal B times A, does it? It didn't work when you changed it around the other way. So you need to make a little note there. Order is very important with matrix multiplication. So it's very important which one is going first and that, because they don't equal each other. In normal maths, we would have said 2 times 3 does equal 3 times 2, but not in matrices. They do not equal, and they may be defined, but they still will produce a different answer. Okay, so order's very important. Okay, so we're just practicing up here. So which of the following are defined, and if they are, what's the answer of the order of the answer they would get? So if you look here, A was a 2 by 2, and we'd be multiplying with B, which is a 1 by 2. So this one we'd simply be saying undefined. Why is it undefined? Because the columns in A does not equal the rows in B. So then if we do the next one, if we've got B, which is a 1 by 2, B, a 1 by 2, with multiplying with A, which is a 2 by 2, well, this one is defined. So it is defined because the number of columns in B equals the rows in A, and our answer would have an order of a 1 by 2. So our answer BA would have a 1 by 2. Okay, if we look at matrix C multiplying with B, so C has an order of a 2 by 1, B has an order of a 1 by 2. This one is defined, and the answer, so say CB, would have an order of a 2 by 2. Okay, and then the last one, we've got C multiplying with A. So this is all, we need to always check whether we can do it before we go off and try, because obviously it'll save you a lot of time. So this one is undefined. Okay, and we just make a note that AB does not equal BA, but we've already talked about that. So this is where we're going to learn how it's actually done. Yes, we can use our calculator to do multiplication, but there is going to be questions where they're going to say, show how the answer is that. So you'll have to show the manual working out. Or there'll be other questions more in the top end where you cannot solve it unless you understand how it's calculated. And the calculator will not be able to produce the answer for you. You have to work it. It'll be you working it out. So when we're going to practice, we have to first think about, can they be multiplied together? So check the orders. So we got a 2 by 2. So we're going to say, yes, it can be multiplied. And then what we're going to do is, what I want you to do is always think about what your answer should look like. So because our answer should be a 2 by 2. So what you're going to be looking at is that you're going to hope to find 4 answers. So here's where those 4 numbers are going to be within that element, because it's going to be a 2 row, 2 column in this scenario. Okay, so what we do when we're calculating it manually is sometimes you'll hear them to refer to as run and dive. So what they mean by that is that they're going to run across there and dive down there. That's how it's going to happen. So you can see that this A is getting multiplied with that E, and then you add B being multiplied with G. Okay, so you do those, the top 2 get flipped and multiplied with the column of the second one. So it's sort of like a run and dive. Now you can always check when you're doing your answers manually, see how this cell here, or this element here, it's in the position of row 1, column 1. So this shows you, this is the row you should be using from the first one, which you can see we are. And the second thing tells you the column that you should be using from your second one, which we are. We're using column 1, okay? So that can be a handy help. So if we go, so if I just rub that out and I go to look at, say, the other, this answer here. So if I look at it, I'm in row 1, column 2. So I go back to my matrix, I'm going to be using row 1 and column 2. Can you see that? Yeah. So A is getting multiplied with F, and then B gets multiplied with H. So you can see that there, and we add those together, and that would be the next one. So I'll just keep going just to help you. So we'll do the next one. So if I'll do this bottom one. So if you look at it, I'm in row 2, column 2. So that means I would be using row 2 with column 2. So you can see the top first one gets multiplied with the first one. So C and F, and then D gets multiplied with H, and you add them together. Okay? So this is a basic, so we don't give 2 bigger ones for you to work out. 2 by 2 multiplied with another 2 by 2 is probably the most biggest one. Otherwise, we might get ones with 1 row, 1 column, but we'll work it out. It's all good. All right, so let's go and practice this one. So what I'm going to do here, I'm going to say matrix A multiplied. I'm just going to do, so matrix A, we're going to multiply with matrix B. So if we first check to see that it's defined, so I've got a 1 by 3 and I've got a 3 by 1. So what I say you should do is you should always check, yes, I can do it. And what I like to do is you've got to write out what your answer will be. Now I know it's going to be a 1 by 1. So what I know then, I always draw it out, even though I've drawn it a little bit bigger, I know in the end I should just have one answer in there. Does that make sense? Because it's a 1 by 1. You would only have one number in there. And so then I can think about it and I'll go, all right, so if I was looking at this cell, it's in row 1 and column 1, yeah? So I'm just going to use these numbers over here, these matrices written out here. So really I'm going run, row 1 with column 1 like that. So what we're going to see over in here, we're going to see 1 times 2 plus 2 times 4 plus 3 times 1. So all of those get done and then you tidy that up. So that would be 2 plus 8 plus 3. So we get 13. So that's a 1 by 1, isn't it? So that's our answer, okay? Okay, so we're going to give these ones a go. So I'm going to multiply, I'm going to do A times B. So I'll just check the order here and make sure that I can do it. So I can, okay? So I'm going to have, I'll write them out again. I've got this matrix A and I'm multiplying it with B like this. So if you think about it, what will my answer be? It will be a 2 by 1. So what I'm going to do is I'm going to set it up and I'm going to do a 2 by 1. I give myself plenty of room because I know I'm going to do some additions in there. But what I'm going to see is I'm going to have a 2 by 1. So I'm going to see 2 rows and 1 column. So I sort of just dot around and I know that's the 2 numbers I've got to have in there. So if you think about this first one here, I'm in row 1 and I'm column 1. So when I go to multiply, I'm going to go row 1 with column 1. So it's going to be 1 times 2 plus 0 times 3. And then the next row, you could go run and dive again. You're in row 2, column 1. So we would have 2 times 2 plus 3 times 3. So then you tidy that up. So if you want, you've got 2 plus 0 and 4. Sorry, there's missing the times there. 4 plus 9, and you could keep tidying that up and you get 2 and 13. So is my answer a 2 by 1? Yep, so we've gone okay. All right, with the next one, I'm just going to multiply it in here so we don't have to write it again. So I'm thinking about it, I've got a 2 by 2 with a 2 by 1, and my answer is going to be a 2 by 1. So what you've got to look at, it doesn't matter that there's letters in there. We said matrices could have letters or numbers. So we're going to write it out and you're going to think about it. You're going to have 2 rows with 1 answer. So I'm going to have 2 elements in there. All right, so you simply do the same. So when we're in this position here, we're in row 1, column 1 in this guy. So off I go, I use row 1 with column 1. So 1 times x plus 3 times y. And then if I do row 2 with column 1, I've got 2 times x plus negative 4 times y. Now you just got to keep tidying it up. Now we can't, so we've got x plus 3y and we've got 2x minus 4y. We can't add or simplify that anymore, can we? Because they're x and y's. So there's my final answer, and there's my 2 elements, yeah?
Yep.
They're just written like that. It's just a little expression, that's fine. So I do have my 2 by 1 answer. So some of the application questions, you're going to see, this is where you sort of need to understand the manual multiplication. So here they want us to display use matrix multiplication. So they're asking me to show it using matrix multiplication, how you could add up, so the sum means add up. How could we add up all the rows? So if you look at this matrix here, we've got a 5 by 5, okay? So when you want to add up the rows, you post multiply with a column matrix. So post multiply means after. So we're going to post multiply with a column matrix full of ones. Now, you know that this would have to match for you to multiply it. So I'm going to have a column matrix of 5 rows, yeah? So you know a column matrix, so you know it's going to be like that. So if you put ones all down your column matrix, you're going to see that would essentially add up all the rows. So if I just to show you, if I did the first one, so if I was finding this first answer here in row 1, column 1, so what I would be using is I'd be going this row with this column. What I'm going to see, it would be 2 times 1 plus 4 times 1 plus 1 times 1 plus 7 times 1 plus 8 times 1. So can you see, essentially, that would add them all up, wouldn't it? Because you're only timesing it by 1, do you change the value of that number? No. So you would have added them all up, and you'll end up with this nice column matrix that has those numbers added up. So which would be 6, 7, 14, what is it, 22? No? 14, yeah, 22. Okay, and then so if I did the bottom one, just to show you, it would have been 5 times 1 plus 3 times 1 plus 6 times 1 plus 7 times 1 plus 9 times 1. So that would have been, what's that, equals 8, 14, 21, 30. Yeah, so you could get that. If you're asked to do a matrix multiplication, so once again we're asked for a matrix multiplication that displays the column sums. So that means we're adding up all the numbers in the columns. So we want to see this. What they're asking, what it says to do, you have to pre-multiply. So here, that means you've got to multiply before, and it says with a row matrix of 1s. So what we're going to see here, I'm just going to copy this matrix out again. So we're going to multiply something in front of this. So at the moment, this matrix is a 3 by 5. So if I've got to pre-multiply something, it's going to have 3 columns, yeah? And we want, essentially with our answer, if we were adding up all the columns, we want to have all those 5 columns across the top with their one answer. So this will be a 1 by 5. Okay, and it says up there you should pre-multiply with a row matrix. So a row matrix always has a 1 in the front because it's one row. So you can see if we do the run and dive, we would go, so I'm going to, create that row matrix. So it would be like here, 1, and I need a 1 by 3, so it'd be 1, 1, 1. And if you see, if we go run and dive, we go run and dive, and what it would do is in this, sorry, I didn't really leave enough room, but in this spot here, we would have seen 1 by 4 plus 1 by 0 plus 1 by 4. And so you would see 8 written there. And if you added up the columns, would you get 8 there? The column numbers? Yes. So see how that works? So this is this is pre-multiplying, so you're multiplying before.